Hello, this is Mariam Toha, and with me is Muhammad Sulaiman, and we're going to be presenting the project Milestone 1 for our project, Speaker Diarization. So this is the table of contents. We're going to be discussing the problem statement, related work and proposed updates, the progress report, the progress on our solution, initial results, and our next steps. So our problem statement, what our project aims on developing is it's developing a deep learning based speech recognition model that can identify different speakers within an audio file. And the importance of this is that it would allow us to create diverse conversation datasets which can be used to train other deep learning models. It can be used to improve various applications like chatbots and sentiment analysis across different topics and areas. And also, for users with disabilities, it's hard to discern the shift between speakers when there are no speaker tags on things such as YouTube videos. So for the captions that have the different speaker tags would make it easier for users with disabilities or who are hard of hearing to be able to follow along as to who is speaking in these YouTube videos. This is an example for the YouTube video for there to be a tag before each speech, so to be able to identify which speaker is talking. And the speaker diarization, this is an example. The automatic speech recognition does not describe who is talking, but for the speaker diarization, there are tags for each speaker, whether speaker 1 or speaker 2, as to who is talking at any given point.
So for the related work and proposed solutions, we have surveyed recurrent networks like LSTMs, different architectures like TOLD and TitanNet, which is our base model. We have seen the accuracy metrics on each of these models, and TitanNet performed the best, that's why we choose it. But after inspecting the architecture more of TitanNet and TOLD, we found out that TOLD deals with overlapping speech, which could be why the metric is higher than the one of TitanNet, but it still gives very good result. So one of the proposed updates is actually combining the architecture of TitanNet and TOLD, hoping to get better results than this one while still working very well with real world data, because that was our initial goal. So this is a TitanNet architecture. It has BN blocks. Each one of these blocks has a convolution block followed by batch normalization and an activation function and dropout, and it is repeated n times. There is a prologue block and an epilogue at the end, and this is the encoder. Then in the decoder, the architecture uses attention statistics pooling to try to focus on the important part of the speech to lower the computational power, and instead of using recurrent networks, they opted for 1D depth-wise convolutions with attention to get very good accuracy while still having lower computations. So one of the proposed updates was changing the TitanNet architecture itself. So what I have done is changing the convolution into an actually a recurrent network, which is a GRU gate, and to see what happens. And surprisingly, it gave lower accuracy than the base model TitanNet one. Even though theoretically I thought that using GRU with attention pooling would still give higher accuracy but would take longer. That's why I also trained up to 5 epochs only on the GRU one, because it took way longer. But the surprising thing is that it actually gave worse results, still very good but worse. But one thing to notice is that I haven't changed the hyperparameters that came with the default TitanNet for the GRU, so that could be a part of the reason why it gave worse results. So that would be one of the things that we would try to do in the future updates in the timeline. Also, I have used Nemo, try to get an actual diarization on an actual audio input from a real world YouTube video.
You're literally the worst at acting ever.
Oh my gosh. Why do you think I'm a VTuber?
Because you're so ugly.
The problems encountered with this was that uh, I couldn't input the whole audio on one chunk onto the model, even though the audio is only 8 seconds, so I had to divide it because of the memory problems. So while dividing the audio into different chunks, it ended up giving an accurate graph in the end, because this up to the green part is actually on the whole 8 seconds, but it still shows up to 8 seconds that is not diarized, even though it is actually diarized, so it's not really accurate. And in the diarization itself, it didn't give accurate results, because it gives that the first sentence is said by speaker 0, and the rest of the audio is by speaker 1, while in fact one of these sentences was also said by speaker 0, so it's not really giving accurate results in the end. So that's one part of the proposed progress updates that we want to continue on, to get accurate results on real data, including YouTube ones.
So for our progress on our solution, what we've done so far is that we've worked on editing the dataset.py file to change the dataset used from the LibriSpeech dataset to the Vox Converse dataset. However, we're still in the debugging phase, because there are errors that are occurring that we still have not fixed. As for our next steps, we're going to be fixing the errors that are showing for the debugging phase. We're also going to change the dataset. We're going to be experimenting more with the architecture. We're going to be changing the hyperparameters. We're going to be testing more on real-life audio and checking how to improve accuracy on real-life applications, as well as trying to do some interpretability analysis. This is the individual member contribution between me and Muhammad. Thank you.